Hey, my name is Uriah Ellis, and I'm going to talk to you a little bit about the ideal gas law for chemistry. Okay, the ideal gas law is this right here. It reads, pressure times volume is equal to the number of moles times a constant times temperature. And the constant is actually really specific. Some really smart guys came up with this by throwing in a bunch of crazy equations and STP and all that jazz. So I don't think I'll go into that too deeply right now. All you really are going to need to know is that for what we're dealing with, this constant right here is just going to be 0.0821, what is it, liters times atmospheres per moles times Kelvin. And all of these different symbols and measurements are going to make a little bit more sense in just a few moments. Alright, so first I'll talk about where the ideal gas law comes from. It comes from these three guys, Charles, Boyle, and Avogadro, thinking about how gases work and how they kind of vary depending on different stresses put into the environment and what those different relationships are. So Charles, what he found out is that volume and that shouldn't be pressure. Volume and temperature. How do you spell temperature? Temperature are directly proportional. This ends up being an equation that says V1 divided by T1 equals V2 divided by T2. And the ones denote before a reaction occurs and after a reaction occurs, of course. Okay. Boyle said that pressure and volume of a gas are inversely proportional. So this says P1 times V1 is equal to P2 times V2. Then Avogadro comes and he says volume is directly proportional to the number of moles in a gas. So V is equal to A, some constant, times N, which is the number of moles. Okay. Now, alright class, does anybody know what a mole is?
No.
Well, that's an excellent opportunity for me to teach you. Okay. A mole is pretty much a great equalizer in chemistry. It gives you a chance to compare different compounds and different elements of different weights depending on their atomic number. The mole says that there are 6.022 times 10 to the 23rd molecules of this particular compound or element that you're looking at in every mole. So 2 moles of carbon has 12.044 times 10 to the 23rd molecules, just like 2 moles of nitrogen has 12.044 times 10 to the 23rd molecules. This makes it really easy to really compare different substances and see how much you can kind of make them interact. So, now I will actually talk about the ideal gas law a little bit. Pressure is in this unit right here, ATMs. ATM is short for atmospheres. Yes, that is a little bit bigger than necessary, but it makes sense. ATM, atmosphere. And that's just the pressure of the atmosphere. I think that it's about, 15.4 pounds per something. So right now we have about 15 pounds of pressure on us. This pressure is necessary for keeping our bodies in order. Without the pressure, we would kind of explode because we wouldn't have anything to keep us squeezed in, locked down. Alright. The first guy to ever really think about pressure, to ever really measure pressure, was a guy named Torricelli. He kind of worked with Galileo, Galileo was pretty smart. He worked with the stars and the earth and stuff. But Torricelli was observing the environment, and he kind of put some mercury inside of this kind of jar, and then sat a plate on top of the mercury, and then set out this other little tube, and he measured how high the mercury got pushed up. Like, here's the jar thingy, and then here's a tube I gotta connect it. and then all this is mercury. Okay. He set up like a little plate, and he let the air pressure push this down until the mercury filled up a certain level. And he found that this level was 760 millimeters. So now we say that 760 torrs, named after Torricelli, 760 torrs, which is also equal to 760 millimeters of mercury. And what is mercury?
Hg.
Hg. Good job, Norquator. 760 torrs is equal to 1 atmosphere. Alright, so that's an easy way to kind of convert between the two of them. Alright. So now we understand what pressure is. Volume. Anybody know what volume is? How about you, Toyin?
No, I don't. What is it, Uriah?
Okay. Volume. What is volume? I think volume is the measure of a what is it? Mass in a particular space. I think that's what it is. What's the units for volume?
Something cubed.
Yeah, space cubed per. What is volume? Dang, I need to know that one. Yeah, it's just some measurement cubed, like some linear measurement cubed. So, inches cubed is a measurement of volume. But of course, since we're not using, what are they, empirical measurements, this is useless to us. So we like to think in milliliter, wait, no, not that, in centimeters or meters cubed. Centimeters cubed is equal to the milliliter, a measure of volume, and the meter cubed equals the liter. Yeah, these are our measures of volume, okay? This is just measuring how much space something takes up. Yeah. So, now we understand what volume is. N is the number of moles, and that was that concept that I was explaining earlier, where the 6.022. And actually, that deals with Avogadro too. That's called Avogadro's number. 6.022 times 10 to the 23rd molecules. That's not how you spell it. Equals 1 mole of any substance. Okay? So that's how you convert between moles and molecules and all that jazz. Alright, here's R, that one little constant that we were talking about. And as you can see, we're starting to figure out what all these different, sorry about the cough, all these different measurements that go into it are for. Liters is the volume, this is the pressure, these are the number of moles. Now all we have left is Kelvin, and the only variable we have left is temperature. So temperature is measured in Kelvin. Kelvin was a guy who did some funky equations and figured out that at 0 Kelvin, all motion in everything stops, because as we know, in every compound or everything made of matter, there's some motion going on in between the individual molecules. At 0 Kelvin, all that motion stops, and there's absolutely no energy in the system, and that's what we call absolute zero. Right now, it looks like it's only theoretical because we haven't achieved it. We've gotten pretty close, but never achieved it. So people keep trying. I don't know if they'll get it or not. But Kelvin is the degrees Celsius plus 273.15. Alright? So, at 0 degrees Celsius, which is freezing, plus 273.15 equals 273.15 Kelvin. That's the freezing point of water in Kelvin. Okay, just add that to anything Celsius and you got it. Alright, so now we figured out what all this stuff in our ideal gas law means. So, let's do some examples. Yeah, let's do some examples. And let's rewrite this so that it looks better. And, it could be kind of complicated to remember this. So an easy way I remember is by thinking that the ideal gas law is perv-nerd. Now, no, there aren't enough letters for this to really work. So that's just what I think of, perv-nerd. Hopefully, it will help you. Let me see. Example.